Hello, everyone, and welcome to our latest Balena webinar. This one's entitled, Is the Raspberry Pi 5 the right choice for your next device fleet? And I'm Alan Boris, the Edge AI Enablement Lead here at Balena. And we're really thrilled today to be joined by two gentlemen from Raspberry Pi, Simon and James, and I'll let them introduce themselves now. Simon, would you like to go?
Yeah, thanks, Alan. Hello, everyone. Good to be with you today. I'm Simon Burgess. I'm Raspberry Pi. I'm sitting in our Cambridge HQ at the moment, Cambridge in the UK, and I am an enterprise business manager. And basically, I work in the commercial team, and I work on the business development side, so the commercial and relationship side of the business.
Hi, my name is James Hughes. I'm a software engineer by trade, I suppose is the right way of putting it. Been doing that since I was knee high to a grasshopper. I've been working for Raspberry Pi for about 12 years. Firstly as a volunteer and then as an employee for the last 7, and that's as a software guy. But now I've moved into the applications team here. So I help out with things like webinars, demonstrations at exhibitions and things like that. Still get a little bit of software input in there, but now my job is really to help out people like Simon and people who are using Raspberry Pi products to make sure they're using the right product for their sort of their use case, and to help them when they have problems. So a lot more technical support now than actual software writing.
Great. Well, thank you very much, both of you, for joining us. Briefly, before we get into the questions, and we have a lot of questions from ourselves and also from our attendees today. So also, if you do have a question during this, please feel free to enter it into the chat. But briefly, let me just mention what Balena is for the few people, I'm sure, that have joined that aren't familiar. But it's basically a secure container-based platform for managing massive fleets of small devices like Raspberry Pis. I actually have a demo running behind me that you'll see. We'll get to that in a little while. But I thought we'd jump right into the questions that we have, especially regarding the topic of the webinar, the Pi 5. So if we just get started with that, let me start with this one. We've seen the specs of the new Raspberry Pi 5. I mean, they're out there. Plenty of people have seen it's very much improved. But in practical terms, what applications benefit from the new features of the Raspberry Pi 5? Where are you seeing that mostly?
Well, it's a great question. I think the benefit is almost everybody, or everybody using an SBC. The Pi 5 is conservatively 2.5 times faster than the Pi 4, both from the ARM core point of view. We're now using A76s instead of A72s, which give you more processing power per clock cycle. We're running them faster at 2.4 gig. The GPU is about twice as fast, 2.5 times as fast as the one on the Pi 4. So there's a general performance increase purely from the SoC change to the BCM 2712 over the BCM 2711. It's still a Broadcom chip, but one of the things about the Pi 5 is the fact we've moved an awful lot of the sort of Pi specific stuff. What makes the device a Raspberry Pi has moved to a chip that we've developed in-house. We now have our own ASIC team. It's called the RP1. We will have I think the next question we'll cover that in a bit more detail. But what that gives you is much better USB bandwidth. The RP1 handles the USB hub. It's connected to the SoC, the 2712, by a 4-lane Gen 2 PCI bus, so there's a lot of bandwidth there. The camera ISPs have been improved. The MIPI ports, which handle the cameras, and the DSI displays, they've been improved. They're now 4-lane instead of 1 2-lane, 1 4-lane. But you mentioned AI. There's nothing specific on the board itself for AI. What we try and make with our SBCs is perfect device. That one way of putting it is we sell a very well priced product. to make a well-priced product, you have to try and avoid using things that people don't use most of the time.
Sure.
So you don't want to have silicon on there that 90% of your customers don't use. The 10% might be a bit disappointed, but that's why we've got the hat system, the hardware on top. And one of the advantages of the Pi 5 now is that you can now connect to the hats with the final 5th PCI channel. So you can connect to hats, and really our aim is for things like AI and that sort of thing to be moved onto these daughter boards. So only people who actually need that sort of performance need to pay for that sort of performance.
Well, that makes sense.
Yeah.
Completely. And yeah, you mentioned the RP1, just like you said, and that's new for this. That's considered the South Bridge. Is that what they call it? That chip. And what are you seeing as far as the the implications in upgrading from an earlier version of the Pi with that chip? I know when I was using the GPIO, I had to switch to a different library. Pi 5. Is there anything else people should keep in mind specifically when they're upgrading from an earlier Pi in regards to that RP1?
I think it's worth to sort of not answer the question straight away, but it's worth saying that one of the targets we've had over the last 12 years is to move away from proprietary APIs and things like that. So we've constantly moved towards getting software out of the closed source firmware, so it's all handled by the Linux kernel. And that means that when we do add things like the RP1, if you're adhering to Linux APIs, then you shouldn't really see any difference. But as you've alluded to, one of the problems has been the GPIOs have now moved from the SoC onto the RP1. And prior to, say, on the Pi 4, there were a lot of third-party GPIO libraries that really relied on the fact that the GPIOs were on the SoC. Now they've moved on to the RP1. As long as you're using these standard Linux APIs, then you're not going to see much of a difference. But unfortunately, people are still using older libraries, which now don't work or don't work as intended or as expected on the RP1 based on the Pi 5. So now we heartily recommend that if you're writing C applications, for example, you're going to move to libgpod, which is a standard Linux API for GPIOs. If you're using Python, GPIO 0, which is a Python library that sits over the top of LGPIO, which is another standard thing. There are a couple of things you need to be aware of when you're moving to these sort of things. For example, the base GPIOs move from GPIO 0 to GPIO chip 4, I think, something like that. So you do need to be a little bit aware of which device you're working on. And there are a couple of techniques that allow you to sort of make a multi-platform thing that will work on a Pi 4 and a Pi 5. But you do have to do that sort of explicit check to see whether you need to do that. With regard to other things, there are, like I said, we're moving away from these proprietary firmwares, and that means that some firmware-based graphics stuff is now no longer. It's not specifically an RP1 issue, but things like the old compositing system, what was called Discman X on the older devices, has been effectively replaced by DRM. Which is not digital rights management, it's the direct rendering manager, which is again another standard Linux API. So we want people to move over to these new APIs, and it means that any future products we will be sticking to those APIs. So at some point you're going to have the pain of trying to move to these standard APIs, and really the Pi 5 is the point where you really should make that jump.
Sure. No, that makes a lot of sense. And moving into some of the more commercial aspects, I think one of the other big questions we have is when to use a type of like a compute module, a CM versus a standard Pi. What is the kind of point where it starts to make sense to think about that transition? And also, that's assuming, I know we have, of course, the CM4. I don't know if there'll be a CM5. I'm not sure if that's actually been, determined, but in any case, I know the CM4 is still very popular, but where do you see that decision point being made usually?
Again, I've got another great question. I mean, the CM4 has been a fantastically popular device. I think we're well over are we over 1 million devices, something like that? Maybe even more than that. It might even be 5 million. I can't remember. Might be 5 million compute modules sold.
That's right, James. Yeah.
Yeah, the CM1, the CM3, and the CM4, over 5 million devices. So they're obviously a very popular device, but it's an interesting question. When should you move to that? I mean, really, they are specifically targeted for people building their own products,
Mhm.
their own embedded systems. Quite often, you might find a Pi has the wrong connectors on it. They're in the wrong place. The Pi itself, the form factor, we squeeze a lot of connectors all around the outside. Just slapping that into a box, it's quite awkward. You've got to have fly leads to take the connectors out to say the connectors on the outside of the box. So if you're at that point where you're looking for dedicated connectors, in fact, we had a case in yesterday. A company wanted waterproof connectors actually on the board. Great example of where they instead of using the Pi 5 or the Pi 4, they should be moving to a CM4 and building their own baseboard. So the choice is, are you going to be building it into a product? Have you got the skills to develop your own baseboard? And it's also worth noting at this point that there's an awful lot of third-party CM4 baseboards out there that might do what you need. We obviously sell our own development board, the CM4IO, which provides all the interfaces. But again, they might not be the ones you want. So you can build your own thing. For example, if you want a CAN bus or something, you could have a CAN bus baseboard, plug the CM4 straight into that. So they're really targeted towards these embedded product-like devices where you're going to start making a lot of things, and you need your own sort of connectors on the outside. And like I said, they've been spectacularly popular. And yes, you are absolutely right. There is a CM5 on the way.
So just can I just add to that? You're just on the CM5 bit. There is one on the way, although we don't sort of pre-announce stuff typically. If you go to our raspberrypi.com and go to the product information portal, there's actually some forward guidance on there, just talking about the sort of high-level guidance of the spec itself. So I can't give you specific timescales, but it's something that the team are working very hard at to get to the market as soon as possible.
Oh, that's awesome. I'm very excited to hear that.
I should say that the CM5 is intended to be pin compatible with the CM4. So for the majority of use cases, you should be able to plug it into a CM4 baseboard.
But also the CM4 is very much live and kicking and will be until 2034, which is the January 2034 is the minimum end of life date that we've got on it. So we see that customers, certainly in the industrial space, who have built a solution on the compute module CM4 potentially, they've got that guarantee that they've got that really long life cycle to make sure they're not having to change every sort of 2 or 3 years.
Oh, that's excellent.
I mean, moving to if really, there's no need to move to a CM5 unless you need the extra performance. It's purely a performance thing. In most of the interfaces remain the same. So if you've got an edge case or your product just needs that extra performance, then that's that gives you the upgrade path. But as Simon said, we're going to continue to make the CM4 till at least 2034. I think it was 2034. I think that's what Simon just said. It's certainly that sort of time scale. So if it does the job, there's no need to change.
Sure.
It's not. We're not stopping making them. Like I said, they've been fantastically popular, really flying off the shelves.
Yeah, that's interesting though. So you're saying that they're basically compatible. So I could theoretically take the CM5 when it comes out and use it in the existing CM4 IO board.
Yes. Yeah. I think we will probably be producing a new IO board to match it, but yes, it will work in the old board. There are a couple of interfaces that have changed. Obviously, the CM4 has 2 DSI and 2 camera ports, whereas the RP1 has only 2 MIPI ports, which can be their dual purpose. They can be either a CSI port or a DSI port. You still have a total of 2. Instead of now have a total of 4. But the use case where you have 2 cameras and 2 displays is extremely small. So we don't expect that to be a major problem.
And I'd like to get more into this, but I know we do have a user's question here, or I should say, one of our attendees. I like to favor the questions that people are asking, so why don't we just jump into this for a moment from Kai. I'd be very interested in hardware D or N coding of video specifically. What kinds of codecs are supported on the Pi 5? So I guess, I would think software-wise, it's pretty much anything, but maybe there's thinking, hardware-wise, what codecs are supported on the Pi 5?
Well, yet again, fantastic questions as always. There's a little bit of, I won't say controversy, but we've actually removed from the 2712 when compared to the 2711. There is no longer an H.264 encoder or decoder. It turns out the ARM cores, the A76s, running at the speeds we're running them, that are perfectly capable. In fact, we're more capable than the hardware encoder decoder. So you can now just use FFmpeg or the standard, what is it? Can't remember the name of the library, but the Linux library for H.264 encode and decode, which actually provides better performance than the previous hardware encoders. There is still a hardware decoder on board, which is for H.265. That's still, we can't, although we could do it probably at 30 frames a second in software, to get to 60 frames a second that we really need, you do need to retain the hardware decoder for that. So from a software point of view, the Pi 5 is just as capable as the Pi 4, more capable in certain areas. And in fact, I think the H.265 HEVC decoder is the same as the one on the Pi 4.
Great. Yeah, thank you. So just jumping back to what we were talking about, the more industrial applications of the Pi, specifically the compute modules, we have a question about when to use an SSD versus eMMC. I think what we mean there is a SD, so SD card versus eMMC. And I would think now eMMC is usually available on some versions of the compute module, correct? So there's the option to switch to that. The Pi, the regular Pi itself is SD only, but now with the Pi 5, I guess you do have the option of using the PCI for an SSD or alternate forms of storage besides the SD card. So I don't know if you could speak to that somewhat, like where you're seeing the best uses for storage other than SD card and when it makes sense to switch.
Okay. I tend to use, when I'm using CM4s, I mean, obviously I work for Raspberry, I don't actually make products, but I use the EMC based CM4s all the time. There's one thing to bear in mind is that on the CM4s, the SD card interface is on the same pins as the eMMC interface, so you can't have both at the same time. So if you've got a CM4 Lite, which is the one without with the SD card rather than the eMMC, they're actually different. I think they're actually a different circuit board, so you can't sort of mix and match. So the choice of whether you want an SD card or an eMMC usually comes down to, do you need removable storage? If you don't need removable storage, then I'd recommend eMMC over an SD card at all points. I mean, if you do need removable storage but want eMMC, then you can add a secondary SD card interface, maybe by USB. I think there might even be some spare pins on the secondary SD card interface on the CM4 anyway, so you could do it. But on the whole, and I think there's another question which talks about the reliability of SD cards compared with these other things anyway. The eMMC is going to be easier to handle unless you need the removable storage, and probably more reliable as well. I have tried in the past to get information on the number of write cycles available on the eMMC, but it's proved to be an extremely difficult number to get out of the manufacturers of the eMMC themselves. Even when you use their products, I've been unable to find it, but I'm pretty sure that the eMMC is more reliable than an SD card. Although that being said, SD cards, if you put in the proper mitigations, can also be extremely reliable.
Yeah, I'll put a little note in here that Balena OS is optimized to reduce writes to SD cards as much as possible because it's an edge optimized OS. So that's one thing that we do. Within reason, it tries to reduce the number of writes to an SD card. But in some cases, depending on the application, there's only so much you can do.
Yeah.
With that. But yeah, you did refer to. We did see another question pop up. And that was from Victor. He said, we've had some issues with SD card corruption on some Raspberry Pi 4 fleets. Does the 5 help us fix that issue? So I know specifically there's nothing that's going to change that SD card, whether it's, what its reliability is, but isn't there the option now with the added peripheral available that you could reasonably use an SSD now or something else on the Pi 5 as an alternative? Not a compute module, but the regular Pi 5 does give you more options now with regards to storage. Is that correct?
Yeah, absolutely. So I'll start back with the SD cards. The SD card interface on the Pi 5 is actually an improved now. I think it's driven from the RP1. It actually runs twice as fast as the Pi 4. So you immediately have double the performance on the SD cards anyway. Obviously, that doesn't affect reliability, although you could argue that the less time you spend writing to an SD card, the less chance you have of an unexpected power interrupting that write.
Right.
So a faster SD card interface will help. We've also got the ability to do, I think it's called command queuing on the new SD card interface, which means that certain cards that support it, and not all of the A1 cards do, and some of them support it in an erroneous fashion as well. But we've done some testing and we've implemented command queuing, which also gives you a boost in performance. So even if you are using the SD card interface on the Pi 5 compared with the Pi 4, you are getting more performance. But as you alluded to, we now have the PCIe connector actually on the Pi 5, and you can already buy third-party hats that provide M2 or NVMe storage. We will be releasing one of those. We did show one at the Embedded World show a couple of weeks ago, so it's an open secret, let's call it, for want of a better word. And they provide a massive, properly huge improvement in performance and reliability, of course, because these are storage devices that are designed not to corrupt, really. And I think you get about a 10. I think no, it's more, or even more than that now. The performance goes from like 80 megabytes a second storage speed to 800. It's that level of speed improvement. Like it's a times 10 level of improvement in speed. And a Pi 5 with an NVMe drive, M2 key NVMe drive thing, really does fly. Properly fast. You're not limited by the storage speed to any great extent. It's worth noting that the PCI Express port on the Pi 5 is just a single lane Gen 2. We can actually boost it to Gen 3, but we don't. Some of the jitter on the signals doesn't meet the Gen 3 specs. Most things work fine, but we can't actually claim Gen 3 compliance. But people have been using these drives using a Gen 3 PCI, and the performance is even higher. So you do get a massive improvement in performance, certainly on the Pi 5, and of course the CM5 also has the same extra PCIe single lane PCIe interface. It does make a massive difference.
Yeah, that's
great.
great.
I think just one thing on going back to the SD card specific point. I think, James, there are certain SD cards that we'd preference over others that we've done testing on, and also, correct me if I'm wrong, James, there's a white paper once again on our product information portal that talks a little bit about optimizing the way that systems can be set up for helping with SD card reliability.
Yeah, absolutely. There's a paper in there to talk about mitigations. As Alan said, the Balena OS tries to minimize writes to the SD card. It's writes that cause the problems. If you get a power off while you're midway through a write, sometimes they can cause problems. Although we have tested quite a number of manufacturers' SD cards, and certain ones are unreliable with random shutdowns. Other ones, we've never had a single failure. So there is some data in our product information portal which describes the testing that we've done and which SD cards
Sure.
have performed the best, really.
Yeah, and I believe we have that as well on our website. If people check it out, look at the storage section. We do recommend certain SD cards that we found are more reliable. So there is a recommendation there for that. And at this point, I would love to jump into the demo real quick, but I think there was one remaining question that we had about a particular codec that was from Kai. And yeah, I just wonder if we can address that. Any chance of AV1 hardware decoding being supported? So now to support a new hardware codec, I mean, can you do that on an existing chip, or is that something that would have to wait for a future Pi, or can you actually add new hardware decoding to an existing device? I'm not sure how that works.
Yes, adding it to a chip is not the cheapest thing to do in the world.
Right.
I think I think to respin a chip, to put something like that on, just to respin it, just to do the new mask, is about $1 million.
Yeah.
So it's not something you just do.
Right.
And that would not include any R&D and prototyping and all that sort of thing. So you can't just sort of take your 2712 and add an AV decoder to it. So it's something that has to be designed in some years in advance.
Sure.
I'm just actually, when I saw the question come up, I did wonder whether it's something that could be done with a hat, whether you could have a sort of encoder accelerator in a hat. I think you'd probably be limited by the PCI bus speed because we've only got a single lane out to the hat. You might not be able to get the bandwidth required for some larger images, because if you think about it, a 4K image at 60 frames per second is a colossal amount of data to be transferring, and I suspect the single lane PCI is not quite fast enough for that. But somebody could run the numbers. It might be a possible thing to do. I just don't know. But it's not something we can just say, oh, we want to put that in the chip we're using on the Pi 5. So I suspect any sort of change like that would have to wait for any hypothetical Pi 6.
Right. I mean, the hardware decoding capability in the current Pi 5 is set, right? You can't change that with software or anything like that.
No, there's no other. There's just the HEVC decoder on there.
Okay. Oh, it's good to know. And like I said, I want to just jump into this demo, make it quick, because I know we still have a lot of outstanding questions, but I did want to show the management of Pis, how one could manage a fleet of Pis using the Balena platform. So I'll just make it real quick, but I created this digital signage kiosk, basically, as an example. So we threw together some digital signage. It's for an imaginary resort around the world. We have these resorts around the world in our imaginary scenario. And this particular Pi 5 I enshrined inside an old cable modem case just to make it look cool, because that looks cool. We added some LEDs, and you can see there's two buttons at the top that also are illuminated. One stops and starts the signage locally, and the other one, if I push it, actually gives info about the device. So it switches to that, and then you can see the device's info on the screen. And I will switch it back. The one thing to note is you can see that we've used the Pi 5's GPU is now accelerated, hardware accelerated. So we're using the software in GPU acceleration on the Pi 5. And this is courtesy of something we call the browser block. That's what the main ingredient of this app is, that it's using something we call the browser block, which is basically Chromium running on X11, showing the URL that it's given on the attached HDMI. So that HDMI is output, and I just have it going into my PC as another camera and also being shown on this screen. But I'm going to start this back up again. And, one of the other cool things, because this is a Pi, and I guess this is what you guys would consider like the epitome of a Raspberry Pi project, because we attach a bunch of sensors and buttons and things to the GPIO to show some of the interactivity of a possible digital signage solution. I have this UV flashlight here, and I'm going to shine it on the UV sensor, and you'll see that the signage app has told us that the UV index is high at our resort. So it's going to show the ads for sunglasses. So we've created a little interactivity with our device. And here it is flipping. So if I take this away, that particular screen will not be in the rotation. So that's an example of our little digital signage kiosk, imaginary. And I'm just going to show how that looks on the Balena Cloud dashboard briefly to show how we manage pies at scale. So I'm going to share my screen here so we can see that. Moment. There we go. So this is just the dashboard screen on Balena Cloud for one particular device. Every device managed in Balena Cloud has its own dashboard like this. And then I'll show that, for a fleet of devices, you get a list of all the devices in the fleet on a map. But just briefly, I'm going to show, since, we have a container-based platform here, these services are the containers that are running. And in this example is something that we put together really quick because there's a lot of pre-built functionality that you can get. We call them blocks, but they're basically containers that have built-in functionality. And one of them we have is called Big Sensor that just searches for sensors on the Pi's I2C bus. And if it finds them, it publishes them. You can see that here. And then they're available through an API and you can just pull them. I already mentioned the browser block, which runs on all of the Pi versions, I believe Pi 0 through the Pi 5. And that just outputs the URL to any connected display. That also exposes an API. So in this signage container, I've just written a very few lines of Python code that basically manipulate the browser and the sensor to combine them together and output it. I'm just going to take a sip here to help my voice. And we have one other container of note here, which is the web server. It's just a simple Node and Express web server. And that just serves up the pages that we were looking at. And just a couple of features. Obviously, there's many features, but I want to just go through some of the Pi specific ones that are really cool. One is that we do have device variables, and I can change how my device acts by just adding a variable here. So I'm going to put in interval, and I'm going to change the interval of these screens down to 4 seconds here. And when I do that, our container is going to restart, and then the screens will be at an interval of 4 seconds each. And one of the things to note here, which is important with, when you're using the Pi as an embedded device, say this is out in our resorts showing off digital signage, is that the device keeps going. Like, even though I've changed this variable, the device doesn't really miss a beat. All these things happen, and I don't have to go to the Pi and reboot it, reset it, whatever. The changes we make here just happen in real time, and if the application is programmed to continue, it will just do that. And that's important when you have these out at various sites where you don't want them to be interrupted. And one of the other quick things I'm just going to show is the diagnostic screen. We can run checks here. I've already run it on this device previously. It takes a few seconds, so I won't run it right now. But this just checks certain parameters of the Pi and then tells you whether or not those parameters have passed. We have things like the OS, the engine, but we also check the memory. We check whether the device is undervolted, which is something I know that's important on the Pis that you want to make sure you are not doing. And then I just want to jump to the fleet aspect of things. So if I go, this is our fleet of these similar devices. Now, in the Balena world, a fleet is a group of devices that are of the same architecture and running the same code release. And you can see all of our devices here, and we have this neat map view. And if I zoom in, we can see our devices around the world. And this is not like a fake screen. We actually have these Pis running around the world. Various Balena employees have been kind enough to add their devices to this fleet. So if I knew for a fact that one of the devices was exhibiting a problem, I could actually click on it and run the diagnostics remotely. So I'm going to one that's a few thousand miles away and just running the checks there. And then I can see, troubleshoot that remotely. You've seen what that looks like, so I won't wait for that to complete. We can also SSH into it. And then I'll say one of the other interesting things is that we have the public device URL. So that's optional. You can turn that on, but I could actually click on this. And now I'm looking at the port 80 output of that device, and it is a secure connection. But if I want to see how the page looks on that device, I could actually just type in the URL. If I know it, and I can actually see, okay, that page looks fine on that device in Canada that is a few thousand miles away. And I think the only other quick thing, because we just have a few more minutes for the demo, and I want to make sure we get back to our attendees' questions. I'm just going to show how we can send a new feature to all of the devices in our fleet. So if I go back to the list of devices around the world, we've actually created, on some of the devices, they are also using those sensors. And we have something called tags. So you can actually put a tag on a device, and I've tagged all the devices around the world that actually have the UV and temperature sensors on them. And I created a new feature that actually reads the temperature sensor and adds it to one of the screens that is displaying in the resort. But I only want to push that update to our devices around the world that are attached to sensors. So I can actually just search here, and I see a list of all the devices that have sensors. And I'm going to push my code to just those. And I can look at the list of releases that we have. I'm not going to get into the whole pushing of the code, but we have plenty of documentation on how you would do that. So I see in my releases of code that this new one does not have the bug that I noted. And I'm going to apply that. And if I go back to my Pi, you'll see that it is now updating. It is updating to that new release of code that includes a particular improvement to how the screen works, and it uses the temperature sensor. And I've actually updated, a bunch of devices, a bunch of Raspberry Pis around the world. And if we could switch to the output of the kiosk, the screen, you'll note that the updated screen is now showing, and it's not this one, but the next one, I believe. There it says it's 84 degrees outside. And well, it went by pretty fast because I changed the interval to 4 seconds. But in case you didn't see, it actually shows the temperature now, whereas before, and it's this screen, before it said it's nice outside. But now with that code update that I pushed to all the Raspberry Pis that have sensors, it actually has the temperature. So that's just a mini overview. There's so many more things you can do Pi-wise with the platform, but I just wanted to show for those that aren't familiar with the Balena platform how you can manage a fleet of Pis. And just one other thing I'll say is, since the fleet is all devices with the same architecture, you'll note that I have a mix of Pi 3, 4s, and 5s in this fleet. And we were able to push the same update to the different Pis, even though they're all in the same fleet, because they're running basically the same architecture. They're all 64-bit capable. And that's pretty much the demo for our management of some Pis. Simon and James, I don't know if you had any questions about that, feel free. But otherwise, we can continue with some of our users' questions.
No, that's good demo. I like the resort as well. That looks very, very appealing.
I highly recommend it.
Yeah.
I was going to say that big fleet management is not something we do at Raspberry Pi. So it's great to see that third-party people like yourselves are really getting to grips with it. It looks great.
Yeah, thanks. We do have some users with thousands, tens of thousands, or even hundreds of thousands of Pis that they are managing in this fashion, and there are easier ways to do some of the things that I showed in bulk. We only have 10 devices in that example, so I did things more the streamlined way, but you have to do things a little differently when you have that many devices. But we also support an API for doing most everything you saw programmatically as well. But anyway, let's jump back into our users' questions. We'll go to the top of the list that I have here, and we have one from Adam, who is interested in 24/7 operation in non-temperature controlled environments. So is there any guidance for using a Pi in that way? It sounds like maybe a CM4 or a CM would be better suited to that, or is that not the case? Does it make much difference?
Well, different products have different temperature ranges. I think the CM4 has a fairly broad temperature range. I think it's slightly higher than the Pi 4 or the 5. We work out these temperature ranges by looking at all the individual components on the board and sort of taking the set of those and getting the limits from that. So we have actually considered and looking into extended temperature range devices. We've already done it for the RP2040 and the Pico, and also it's something we could do for the CM4. It does require new components on the CM4, but it's certainly something we can look into for extended temperature ranges. I think from sort of -40 to +85, something like that. It's worth noting that the devices can get very, very hot without failing. I mean, we test the devices to over 100 degrees, and they still run. I mean, I've seen standard CM4s running in an oven, running at where the oven's at 80 degrees. The CM4's running at over 100 degrees, and it's still working.
And
so they can get extremely hot. They will throttle themselves. Obviously, anything as many of your that people watching would probably be familiar, at 85 degrees, they throttle themselves right back to reduce their temperatures. But I mean, even when fully throttled back, if you're in an extremely hot environment, they will just get hotter and hotter up to a point, and they still run. I mean, the silicon is extremely robust. I mean, the silicon itself will run to at least 125, I should think, if not more. It's the rest of the board that starts to get a bit strange at those sort of temperatures. So although we do have official temperature ranges, and we don't advise you go outside those temperature ranges, they will try.
Sure.
They will try and keep going.
Yeah, Adam, if you've got more information you want to share with us in terms of the particular environment you're looking at, we'd be interested in taking a look and giving you some guidance on that.
Yeah.
The other point there was the 24/7. Yes, we've got people who've run Pis for years and years and years with never turning them off. So they're more than happy to run at those 24/7.
Yeah, and I think I'll also, to what you said, Simon, I'll take this opportunity to mention if anybody does have a question that we don't cover and they need to get in touch or want more information, to email us at hello@balena.io. You see that on your screen now. If you need any follow-up on anything that we've discussed today, and you're watching this, please do email us, and we'll get you in touch with Simon or James or whoever you need to, or anything that you saw in the demo that you'd like more information about, or even if you'd like a one-on-one demo for something that you need more clarification about, please do get in touch with us. And also for everyone else, we'll just send out a follow-up email with a link to the recording. So just wanted to mention that before I forget. But we can move on to a few more of our questions here. We kind of touched on this one from Marius earlier, but we could maybe expand on it. It's asking, will the transition from Raspberry Pi 4 to Pi 5 be plug and play? If not, what should we expect? I guess we talked about that. A lot of it is based on the RP1 and any changes that went along with that. But James, you mentioned if you're using standard Linux, it's not as much of an issue when you're upgrading. Is there anything else people can do to smooth out that transition?
Well, yeah, as we mentioned earlier, there are changes. I mean, and as you just said, if it's just a bog standard Linux application, it will almost certainly just work. It's when you're starting to use some of the firmware-based APIs and things like that. For example, I did mention Disman-X, which is what the Pi's 1 to 3, and then some of the 4, depending on which operating system version or which firm you're using, was the way to do sort of compositing and graphics and compositing video over things. That is no longer present on the Pi 5, so Disman-X just doesn't work. So we recommend DRM and Wayland, which is our sort of the backend we use now for the desktop. Although X will still work, but Wayland is a more accelerated version. So the plug and playness of it all is going to depend on what your application actually does. I know that the digital signage people, they have taken advantage of Disman-X, because it gave you some facilities that you couldn't get just using X Windows as we had in the past. So there is some work required if you're using things like that. But if you've taken advantage of the new libraries we've had for sort of the camera libraries, we've moved away from the firmware-based camera support to a purely Linux ARM side with libcamera, which is a relatively new library for Linux. But we are heavily involved in the development of that. We talk to the libcamera team all the time. So there's that. So if you're using that, it should just be a relatively easy process. We do intend the big one, certainly for the digital signage people and people who are trying to do very fast screen updates and graphics and that sort of area, is this Disman-X to DRM change. And we will be providing some help on that with example programs and that sort of stuff, certainly for raw DRM and then for Wayland and DRM. Excuse me a moment.
Sure.
Too much talking.
Yes.
And also when you're starting to do that sort of thing in the browser as well, we intend to provide sort of example programs on making that transition.
So it's a lot of testing also. You'd want to definitely do testing and troubleshooting before just throwing a Pi 5 out as a replacement of a 4, especially if it's in something critical or hard to reach.
Yes. We heartily recommend testing everything very thoroughly. I mean, it is a major hardware upgrade, and it does some things. Although they look from a high level view, everything looks the same. Under the skin, a lot of things have changed. So we would heartily recommend proper testing, as we would with anything really.
Yeah, absolutely. And I think this next question is also sort of in that same vein. This is from Jose about the Pi form factor, and pardon, he asked, is the Pi form factor a burden? I don't know about that. The header lacks USB or PCIe. The mini HDMI connectors always require adapters. What would you change if you had to design it from scratch? I think the CM, the compute module, is probably a big answer to that question, but does pose something interesting. I know you might be a little bit locked into certain things with the Pi form factor, but I mean, is there anything you would change? I think they're perfect personally, so but I love them. But if you could do anything, is there anything you might change, or would you just refer somebody to a compute module if they have a problem with the form factor?
When I saw the preview of this question, I thought, well, that's a good question. Effectively, we're locked into this form factor, and as you can see by the fact there are third parties out there, I won't call them clones, but the third parties have replicated the form factor. And as with anything, after 12 years of using the same form factor, you think, oh, I wish we hadn't done it like that. Now, I'm going to put my cards on the table. I'm not a hardware designer. I didn't design it. But you can certainly see why people think, oh, God, there's connectors on every edge, which makes it difficult to put into products and things like that. But that is, exactly as you said, if you're going to put something in a product, you want the connectors where you want them. So the CM range is really what you should be looking at anyway. But
Right.
certainly, I'm sure if we asked some of the hardware guys, certainly James Adams, our COO, who has designed many of the Pi SBCs, including the 4 and 5, I'm sure he'd say, "Oh yes, I wish we hadn't done it like that." But backwards compatibility is extremely important to us. We want you to be able to plug it into most situations and have to make as few changes as possible.
Sure.
And I think that sort of trumps. If we completely change the form factor for the SBCs, I think that the hit we'd take on backwards compatibility would be too high. It's very important to us.
It also seems like it's become a standard. I've seen plenty of other boards that say Raspberry Pi sized, so it seems almost like it's become a convention in a way, the Pi form factor. So
yeah, indeed.
Definitely. And then we have another question here from Valentin. Let's see. Comparison to Pi 4, especially energy consumption, longevity, stability. And I think we probably have touched on most of that, but I don't know if there's anything, I guess energy consumption, it seems, that each new generation of Pi has, of course, new features, but also it seems like they probably use a little more energy. I know that you need a beefier power supply, right? Or you recommend a beefier power supply with the Pi 5. So that's pretty much a trend that we would expect then, right? That there is more consumption on the 5.
Well, I mean, you're getting a lot more performance, and
Sure.
you have to pay for that somehow, and that the payment is more electricity required effectively. I think it's worth noting that if you run a Pi 5 at idle all the time, I think it uses less power than a Pi 4 running at full speed, but it actually still has more performance than a Pi 4 running at full speed. So I think the what would you call it? The work per watt is actually improved on the Pi 5. I have to be honest, I use my Pi 5s with a Pi 4 power supply, and I don't have any problems.
Very unofficial.
But if you're going to be plugging a lot of USB stuff in, well, to be honest, the Pi 5 I have here has no, it doesn't have an active cooler on it, but it has the NVMe, the M2 hat on it. And I'm using it off a Pi 4 power supply. In fact, I don't think it's even a Pi 4 power supply. It's a power supply that I got when we were testing before the Pi 4 was released. So it's some random plug-in power supply that has a USB-C on it.
Scared to hear that. I'm so scared of using the wrong power supply with my.
And I'm using that, and it's working fine. So I do get the warning coming up on the corner that says it's not a 5 amp power supply, and downstream USB ports are limited. I could overwrite that as a config.txt entry to say actually assume you've got 5 amps. But I've not had any problems with it. It's not died of lack of power. So whilst we do recommend the Pi 5 power supply, and it is a great supply, it's cheap, it's very high quality, very high quality, and it does have it's a proper USB PD supply, so it does the up to 12 volts, I think. So it's a top-notch power supply. So I would heartily recommend getting one, but you can get away with a Pi 4 power supply.
Right.
I'm trying to remember what the original question was.
There was a bit about longevity there in the question, and I'm not sure if that's relating to the overall life cycle of Pi 4s and Pi 5s. But even if it's not, let me say the Pi 4 is going to be in production until 2034, January 2034 at the earliest, like the CM4, which we discussed before. And at the moment, Pi 5 is 2036 is what we're able to commit to, January 2036, which is the minimum end of life. So we see them as certainly a long life cycle.
Excellent. Yeah, that's. I think that's very good information for our audience to know. So that was a good question. Let's see, we have a new question here. Dependency of micro SD on stability and speed was my major concern to replace Oh yes. So I guess, I mean, the Pi 5 is out and set, but do you foresee ever having eMMC on, a Raspberry Pi form factor? Is that something under, that's under consideration, even if you can even speak to that?
Um, I think it's unlikely. I mean, it may sound an odd reason, but if you just have eMMC on a board, then you're limited to the capacity of that eMMC.
Mm-hmm.
If you want to have a range of eMMCs, you're suddenly your production and your SKUs go through the roof. The number of different options you have to have. You want 32 gig, you want 64, you want a terabyte. Who knows what the end user wants?
Right.
So it's actually, I think, a better option to use a hat with an NVMe drive.
Mm-hmm.
So an M2 hat, something like that. Certainly, if you want to use mini PCs, that's certainly what I'd recommend. I'd have a Pi 5 active cooler and then an M2 hat on top with whatever storage capacity you need. So 128, 256, that sort of thing. I can't see, although I can't say for certain, but eMMC on the actual SBC range really massively complicates things, and
Sure.
you are specifically limited to what that eMMC has. It's not something you can't take it off and put a bigger one on. Put it like that.
Yeah, and if somebody would really like eMMC, the compute modules are not, out of reach even for the average person. So that's always an option if you really want eMMC.
They're certainly much more common, and you can actually buy CM4 baseboards that look like Raspberry Pis.
Oh,
so
yeah, right.
they've got the very similar connector
Yep.
capacity and that sort of thing. So you can just put it out. There probably are some that look so much like a Raspberry Pi with a compute module on, and that's all they are. So you could get the same form factor, but once I really do think once you're using a CM4, then either designing your own baseboard or looking around to find one that does the job is the way to go in those sort of circumstances anyway.
Yeah, that's right. I've completely forgot. I do have a few I/O boards for CM4s. They are the same size as a Pi. So if you really want that experience, I think there's enough options out there to be able to get that any way you want. So that makes a lot of sense. And I think we have time really for just one more question. So why don't we take this one here? We experienced with the Pi 4 that it's pretty picky on voltage, which leads to issues with certain battery boost converters. Are there any improvements to be expected with the Pi 5?
Well, all Pis like a solid power supply. Well, all SBCs like a solid power supply.
Sure.
The warnings start to come up when you go below 4.65 volts, I think.
Mm-hmm.
The Pi 5 has the same power management IC as the Pi 4, which is a Dialog DA9090, which is quite a nice device. It can do a lot of produce a lot of different voltages which we require on board. But the Pi 5 does have some extra circuitry around it to make it more robust in that respect. So I would expect the Pi 5 to be a little more robust in that respect.
Mm-hmm.
Yeah.
Great. That's very good. I guess that is pretty much all the time that we have. So I just want to thank you both for joining us. It's really great to have this conversation with you and to speak to Raspberry Pi directly. I'm really quite honored, actually, to speak with both of you. And I know that our audience has also appreciated it. And I just want to reiterate also any questions that we didn't get to or anything that that people would like more clarification on, please do email us at hello@balena.io. I think we put that on the screen. There we go, hello@balena.io. And just also want to mention our next webinar with the Edge Impulse coming up on June 20th, 2024. So there we go. Please look out for that. Thank you very much. And thanks again to James and Simon, and also my producer, Thomas. Thank you very much. And thank you all for joining us.
Thank you.
Well,
thank you very much.